Starting this section, we're going to learn how to prove trig identities. So when we prove, we have a certain rules we have to follow. First, we want to only manipulate the left-hand side. So on these proofs, there are always two sides. One, they're all separated by equal sign. So we can only change the left-hand side, and we usually call that LHS, until it looks like the right-hand side. Okay, the right-hand side is RHS. Now, sometimes that doesn't really work because the left-hand side there's not much you can do. So then, number two, kind of the strategy is you want to start with the more complicated side and then work towards the less complicated side. So sometimes the right-hand side is more complicated, you start on the right-hand side. And the next is another strategy. If you just can't figure out how to do it, like you just can't make the two sides equal to each other, sometimes it helps if you just change everything to sine and cosine. And then hopefully now that you got everything down to the basics, maybe you can make the match. And number four is just a warning. Just be mindful of the target. So the target is the right-hand side. You want to make sure you're going towards the target and not just changing whatever looks right to you at the time. You want to go towards the target and you want to favor manipulations that get you closer to the goal. Sometimes you can get really fancy with your manipulation, but it takes you farther and farther away from where you want to be. So please just be mindful of it. And then you want to just write the steps out clearly. Okay, so there's no magic miracle that happens and then you get to the answer right away. If that happens on the quiz or test, I will not give you points. I need to see the work instead of like everything was done in your head and I just knew that it looks like the right-hand side. That won't work. Okay, so for example, this one. So this is the left-hand side and this is the right-hand side. We want to make the left-hand side look like the right-hand side. So let's think about what you want to do. So, the left-hand side is very complicated. We want it to make it look like a 2. So let's look at something and see if we can see anything kind of interesting that pops out to us on the left-hand side. So first, we can try what we did before with common denominator. But in this case, it might not be the easiest way. What I see is this x squared minus 1. And then when I see x squared minus 1, that reminds me of difference of squares. So I am going to factor. Okay, and I can see that these factors are going to cancel, so then I have left with x plus 1 minus x minus 1. And then I'm going to simplify that. X plus 1 minus x plus 1. That's going to cancel and I get a 2. So I got to my right-hand side by only changing the left-hand side. So that's an algebraic example. Now we're going to do some trig examples. Okay, prove the identity. Left-hand side is the right-hand side. All right, so I don't know what to do. Maybe you see the tangent, cotangent, and you're thinking of something. Maybe you can think of this as 1 over tangent and go from there. That's totally fine. I'm thinking of just sine and cosine because sometimes I'm not that creative. So when I'm stuck, I don't know what to do, I change everything to sine and cosine. Okay, so hope for the best. Okay, not quite sure what to do next. So I'm going to multiply by common denominator. Oops. So then at least I only have one fraction to deal with. Okay, in the numerator I have sine squared plus cosine squared. And then in the denominator I have a sine x cosine x. Okay, I know that sine squared plus cosine squared is 1. So 1 over sine x cosine x. And I need to look over on the right hand side before I get too crazy with my simplifying. What I want to get to is secant and cosecant. So I can see here that this is really 1 over sine times 1 over cosine. So that means I get to my secant cosecant, or cosecant secant, but it's the same. Okay, so this is where, example of how to use strategies 3 and 4. So when you can't figure out what to do, or if you saw something else, you can try that too. Let's say you just can't figure out what to do. You would change everything to sine and cosine, simplify as much as you can. But once you get to a point where you kind of simplified everything, you want to just look over it and say, okay, I'm trying to get to secant, cosecant. And how do I get there from here? Instead of just trying something else, you want to just be mindful of your target. Okay, let's try another one. This one's a little bit tricky because there's just nothing that looks similar between the two. Again, what you want to do is only change the left-hand side. So maybe when you saw this, you were just like, let's cross multiply. Yes, cross multiplying will get you to both sides looking the same, but that is not the point. The point is you want the left-hand side to change to become the right-hand side. So no cross multiplying. Okay, we want this to look like the right-hand side. So kind of think to yourself, what is similar to between the left and right, and what is different? So hopefully you kind of notice that cosine kind of switches places, and then you have this kind of switches, but also a sign change. So that's kind of interesting what you want to do there. I see this 1 plus sign and then 1 minus sign. That kind of, again, reminds me of difference of squares. So maybe what I want to do is multiply this expression by, let me rewrite this expression, and then say that, let's multiply by 1 plus sign on both sides. Oh, sorry, on top and bottom. Because I did see that 1 plus sine, 1 minus sine. So I know that it has something to do with difference of squares. And since it switches places, then maybe I can do that to get me somewhere I want to be. Okay, so it's going to be cosine times 1 plus sine t over. In the denominator, I have a 1 plus sine times 1 minus sine. That tells me I'm going to get a 1 minus sine square t, because of a squared minus b squared. Okay, be mindful of the target. Okay, I see that this part reminds me of sine squared plus cosine squared is 1. So I can see that if I just subtract sine squared t on both sides, I would get cosine squared t. Okay, so not changing the top at all. Change this bottom part to cosine squared t. Look at the target again. Okay, I'm very close. Just cancel that. And then I get 1 plus sine t over cosine t. Okay, so this is again where you gotta look for some pattern, and that pattern is gonna lead you to try something that's closer. Again, if it doesn't work, you can always try something else. Just don't make any algebra mistakes, because if you're, somehow like canceling this, and then you made it a cosine over cosine minus cotangent, you will never get there, because that's the wrong algebra to begin with. All right, so time for practice. Go ahead and pause the video and try this, and then come back once you have it, and then check the answer. All right, did you get the answer? So this one's pretty easy. Just looking at the target, you can see that there's only cosine and sine, so that means this cotangent and tangent has to go. So then the fastest way is just change everything to cosine and sine, and then go from there. All right, give the second one a try. and come back and check the answer. Okay, so please check your answer. You don't have to do it the same way I did. You just have to get to the right-hand side without changing the right-hand side. All right, let's do one more and then we will just kind of stop for the day. And you can try these proofs on your homework. Okay, we're gonna skip this first one because that one is really complicated. We'll save it after we practice a little bit. Let's try this one. So looking at the right-hand side, I can see that there's a bunch of sines with different degrees and a cosine, one cosine. And then on the left, I have sine squared cosine to the fifth. So that tells me that every cosine has to go except for one cosine. So that kind of tells me that I'm going to change this cosine fifth from cosine fifth to 4 and then 1 cosine. I recall that sine squared plus cosine squared is 1. So that means cosine squared is 1 minus sine squared. Okay, since I have 2 cosine squares because it's cosine to the 4th, let me try that and see where I get. Okay, at least I change everything to sine only except for 1 cosine. Let's try to multiply them together and see where we get. So this is where you want to just use your foiling skills really quickly in your head. If you can't see it, this is basically 1 minus x squared times 1 minus x squared. Okay, so just foil in your head, square the first term, square the last term. That's going to give me a plus sine to the 4th. Take the product and double. So that's going to be minus 2 sine square x plus. Okay, look at the target. I think I see it. As long as I distribute the sine square, I am done. Okay, that's it. So let's go ahead and just have you start on homework because the other ones are gonna get pretty tricky and we'll practice that tomorrow.